This week we're going to talk about combining different tables into a single query output. So basically we're going to combine different tables in different ways to come up with a single report that is derived from many different places. Before we get started though, I'd like to take a look at or revisit database design from DB1. You're looking here at what many of you may recognize as a database table that has not been normalized. So there's a lot of repeating data. You can see there's repeating data in both the vertical and horizontal direction on this table. So for instance, the item numbers repeat, the customer names repeat, the salespeople repeat. So there's missing spaces there because they should be repeating. So this might be an example of a report that somebody gave you and said, here's a report of our invoices. Make me a database that stores all this information. So when you look at this, you might say, well, I know I'm going to need an invoice table, and that invoice table is probably going to have a date, and we're going to need a table for the customer, a table for the salespeople, maybe a table for items. So you might make something that looks like this as you start your ER diagram. And then you'll start thinking about how these different entity types relate to each other. So you might say that the invoice can have one or many customers, and a customer can have zero or many invoices. And then the invoice could also have exactly one salesperson, but a salesperson can be on an invoice zero or many times. Hopefully more than zero, or else they won't be a salesperson for very long. Then we get to the item table. It gets a little bit more interesting. We know that an item can be on zero or many invoices, and an invoice should contain at least one or many items. The problem is, with database design, we have no easy way to create that relationship. So the physical database design doesn't let us create this many-to-many relationship. So anytime you have a many-to-many relationship, you have to insert another table to create that relationship. And once you would put that table into your ER diagram, generally you would pull the relationships across that table, as you see here. So that little table is now going to proxy the relationships that we had in our logical ER diagram. And then we can put in our one-to-one relationship. So now we have a one-to-many relationship between the line and the item, and a one-to-many relationship between the invoice and the line item. But that effectively gives us a many-to-many relationship between the item and the invoice. We may also have some other tables that we would create. So we would continue doing this in a database design. We would keep drawing out all of these relationships between our entity types. Once we're done, we would end up with a database perhaps that looks like this. We've got 6 tables here. I'm sorry, 5 tables. We have 5 tables. There's a table for the invoice. That's what you see in the center of the screen. On the right-hand side is our customer table. On the left-hand side is our line items. That was the table that connected the items to the invoice, and then the items are down at the bottom. And we've got some salespeople in a salesperson table. So these tables are related to each other through foreign and primary keys. So there's a foreign key on that item table which relates to the primary key on the item table. So we have our line item which relates to the primary key in the item table. And then likewise we have a foreign key in the line item table for the invoice number which references the primary key in the invoice table. And we can keep going. The sales has a foreign key, invoice has a foreign key for the salesperson. And then we also have a foreign key for the customer ID from the customer table. So as we start to write our SQL queries, we have to have a way to connect all these tables together to basically show what we saw in the very beginning, which is our inventory or our invoice report. So this might be a report of orders. And it looks pretty much exactly what we saw in the very beginning. So we took a unnormalized not normalized, 0 NF, whatever you want to call it, or 1 NF. We normalized it, created all these different tables, but now when we present it back to the user, we have to present it in the way that they gave it to us in the first place. Humans obviously don't really, we're not very good at putting together these relationships in our head as we look at a report. There's no way you can possibly memorize all of the different foreign keys if you're looking at a report. You can't say, well, I know that foreign key ID 22 is for phone number 555-12345. You just wouldn't be able to do that. So that's what brings us to this concept of combining multiple tables. So there's two approaches that we're going to talk about for all of these different ways of combining tables. We'll start with the traditional approach, which just uses a where clause. And then we'll also talk about a new keyword, which is join. So the way we write a join is we select our column names, and then we put our table name, but then we put the join keyword followed by the second table that we want to join to the first table. And we also have to tell it how to connect the tables together with the on keyword. And then you could have your where conditions. The reason I'm showing you the where condition in the bottom one is to show you that there's a separation in the join approach between the where condition, the where clause, and the remainder of the query. Whereas the traditional approach, we have a where clause, but it contains both the logic for how we're going to connect these tables together and any additional conditions in our query. So it can be a little confusing when you use the traditional approach if you have a complex query. I prefer the join method because it gives me a clear separation between where I'm defining how to connect my tables and where I'm actually using my conditions for my query. So we're going to start with the simplest form of connecting tables with Oracle. It's a Cartesian join. And a Cartesian join is very simply adding two tables together. So let's say I have two tables. On the left is my customer, on the right is the address table. And you can see that some customers have multiple addresses, so each one of these customers actually has two addresses. In any event, if I were to write a very simple join where, and actually there is no join here, there's no condition. So without any condition, if you just tell Oracle, select from two tables, and you give it a bunch of column names, it's just going to combine them. So let's see how this works. So we start with the customer name in the first record of the first table, and then we combine it with the first record in the second table. And then we keep combining those records in the second table until we get to the end of the table. So it's a very simple addition. There's no condition here for this, so it just keeps going and going. When we're done with that first record, we move to the next one, and then we add all the additional records, and then we do it again for the third record. So whenever you do a Cartesian join, if you multiply the number of rows in the first table times the number of rows in the second table times the number of rows on any additional tables that you try to join, that will give you the number of rows that you're going to see in your result set. Now, you may be thinking, how is this useful? I mean, we're looking at basically a table here that's showing that all of these customers have all of these addresses, which we know is not true. And in fact, in my experience, many times when I see a Cartesian join or the results of a Cartesian join, I know that there's something wrong with what someone did. Somebody didn't properly format their join or didn't properly provide some kind of condition to connect tables. So I know that there's a problem. But there may be circumstances where Cartesian join can be used, and that's a good discussion topic. So on the discussion board, you'll see a question where I ask, where might you use a Cartesian join? It's a good thought exercise. In any event, you can also use the join keyword, but you have to use cross join. So if you see a join when it says cross join, you're explicitly telling the database engine, I want to join another table, and this is going to be a Cartesian join. So cross join is basically means give me a Cartesian join of these two tables. So let's move ahead to our equality joins, and I think these are probably the most common joins that you would see. And let's look at an example. We have, again, same two tables. The left side I've got a customer table. On the right side I've got some addresses. And I want to join these two together, but this time I'm going to do it the right way. So the first customer, Andrew Wiggins, should only show that he has the address of 1 Gettysburg Court and 1 Carthage Drive. And then Dink Meeker should show only Bull Run and Hoax Run. And likewise, Karen Kirby should only show Lexington Court and Allegheny Avenue. If I format this, if I do this join correctly. So let's start with the traditional method. So I have two columns, both called CID, and they both contain in that column the customer ID. Important thing here is that both columns have the same name. So in my join, if I just do where customer.cid equals address.cid, it should take the first record, combine it with all of the matching records in the joined table, and then give me a result. And then it's going to keep going and putting them together, and then what we end up with is the table that we were looking for, which shows all of our customers' addresses. And if a customer has more than one address, they're listed multiple times. We can also do this using the join keyword. Because both columns have the same name, we can use natural join. So a natural join will combine two tables, but it will join them using any columns with the same name. So continuing on natural join, let's say we have two tables that look like this. Notice what I did here. I added an ID field to both. Maybe this is just a sequential control number or something like that. But they both have a column called ID, and they both have a column called CID. So if you do just a natural join, it's going to assume that you want all of the columns that have the same name and the same data type to be equal to each other. Now, of course, if you look at these two tables, that's never going to happen. They're never going to be equal to each other. So this isn't going to work, just a natural join. So we have to have another way to join these together. So the other method that we have is the using keyword. So we can join address. So we're selecting from customer, and then we're going to join address using the CID. And that tells Oracle, make sure you use just the CID, don't use the ID. So it's not going to, it's telling it, don't use that ID field. We know we don't want to use that one. So in this case, it'll just use CID, and we'll end up with the results that we're looking for, even though we have multiple columns with the same names. So another example of an equality join. So this time I've got two columns with two different names. There's no common names here. So I can't use the using keyword, join using something, because they're different names. So with the traditional method, this is pretty straightforward. I just do where customer ID equals address.cid. I know that those fields represent the same thing, so I just make sure that they're equal to each other. So again, that's the traditional method. Using the join approach, oh, and by the way, before I move on to the join approach, just want to show you that we can alias the column or the table names, and this is pretty common when we start doing joins because it's a pain in the neck to type out your table names, and there's some reasons sometimes that we have to use these aliases. So going forward in my presentation, you may see me start using aliases, mostly because otherwise it would go off the screen. I don't have enough room for all the joins that we're going to do. So you just put a alias after the table name. In my case, I'm just using single letters, but you can certainly have more than just a single letter for your alias. And I underlined here where the aliases are, so you can see those. So anyway, moving ahead to the join method. So when we do a join and we have two different named columns, we select from the initial table, which in this case was customer. We're going to join address, and the on keyword tells us how to join those together. And in this case, it's going to be address.cid equals customer.id. So it looks very similar to our where clause. And again, with the join, I can also do my column aliasing, and this is what it would look like with with table aliasing. So another equality join, let's say we have more than two tables. So far we've been just playing with with two tables, but now we've got three tables to join. So join, you can combine more than just two tables, and it's actually pretty common to do that. So let's see how we would do that. In this case, I've got an invoice table, and we have a customer table, and we know that those two should be joined on customer equals ID. So we've identified those, so I'm going to add then again, this is the traditional approach. I'm going to add the where clause, and then I'm going to look for my common columns for my sales or my invoice table to the salesperson, which I've highlighted in blue, and then I'll just do an and add that additional condition. And that'll work. That'll give me a new table, or my results, and you can see them on the right hand side. So now it's going to show both the salesperson and the customer with their invoice. We can also do this with the join approach. So just like before, we identify our two columns that we know we want to join on. We add the join keyword. We use the on keyword to tell it how to put the two tables together. And we just add another join. So there's a second join for the salesperson. And you could keep doing that. You could add additional tables. I'm sure there's a limit. I can't recall off the top of my head what the limit is, but you can certainly join a whole bunch of tables together if you needed to do that. And just showing you at the top that normally best practice when you do this is to put an alias or put the table prefix for the columns. And you would want to do that just so there's no ambiguity. If for some reason you had multiple columns with the same name, as you join these tables together, you want to make sure that they're unique in the select. Otherwise, you'll get an error message. But as general rule, I usually would prefix my tables. In most database engines, you have to do that. Oracle, in some cases, will let you do this without the alias or without the prefix, but something like Microsoft SQL Server or MySQL, you really ought to do that because it's going to give you an error message. And there's my table, which combines the results. So sometimes we might want to do a join and we can't use the equal sign. So far we've done joins where everything is equal. So some ID is equal to some foreign key, and that's how we connect these tables together. But take a look at this example. I've got a list of items in my inventory, and then I have a shipping schedule at the bottom, which shows me the price of shipping based on the weight. Typically, you wouldn't have a shipping schedule that shows specific weights. It's usually a range of weights. So if I wanted to generate a report that shows me the shipping cost for all of the items in my inventory, I would have to join these together, but I can't do so with the equal sign. So first, let's take a look at how to do this with the traditional method. So I have the pounds on my item table, and I know that that needs to be greater than the minimum pounds and less than the max pounds. And then that should give me my shipping costs. So to do that, we just use a where clause, and we already learned how to use the between keyword. So this will return all of the rows in the corresponding table that are between min pounds and max pounds. If there were multiples, then we would see multiple results for each inventory item. But in this case, there would only be a single result, and that's what it would look like. So you can see that the widget would ship overnight for $2.50, or for standard delivery it would be $1. And likewise, the Who's a McCall It or Who's a What's It would be $8 overnight and $4.50 for standard. Now let's take a look at this using the join method or the join approach. Very similar. I just joined the shipping table. Here I'm using table aliases so that I could fit it all on the screen. But I add the on keyword, and this time instead of one column equaling another column, we're going to use the between keyword again. So if the pounds is between min pounds and max pounds on the shipping column, I get my results. Occasionally, you might have a join where you're actually joining a table back to itself. So in an ER diagram, that would look like a unary relationship. So anytime your relationship goes back into its own table. And to show you an example of this, I created a little table of people, and these people may have a spouse. So there's a unary relationship there, where somebody in the table relates to somebody else in the same table. So to do that type of join, first we identify the columns we want to join on. Very similar to what we've been doing before, but now instead of being in a different table, the two columns are in the same table. So I want to join this table to itself, where the spouse is equal to the primary ID. However, in order to do that, I have to sort of virtually join this to another table. So somehow you have to show that relationship. So you can conceptually think of this as creating sort of a virtual table and joining to that virtual table. And the way you do that is you use your table alias. And so this is a case where you have to use a table alias. And you select the same table twice, but you give it a different alias in each select. And in the where, so this is the traditional approach, in my where clause, I do F, which would be for family. The spouse field is going to be equal to my spouse table, which is really just the family table, and it's the ID of the spouse. So this will combine the two together, and we end up with a table showing us all of the people in our database and to whom they are married. We can also use the join keyword to do this, and this is what it would look like with join. Very similar, and again we've got our table aliases, and then it's a simple equality join, which we've already learned how to do. Another method that we use for join is the outer joins, and in this scenario, take a look at those two tables. You'll see that there are customers who do not have invoices, and there are invoices for whom there is no customer. Now, ideally, this wouldn't happen very often. So, if you look at the relationship, we said that an invoice must have a customer, but a customer doesn't necessarily have to have an invoice. So it is certainly possible with our database design that we've got customers that are not associated with invoices, but it should be very rare that we have an invoice for which there is no customer. That should not happen. And in the discussion board this week, you can talk about how or why that wouldn't happen if you design the database properly, and you can talk about referential integrity. But let's say for a moment that we don't have any referential integrity and this could have happened. Either way, we've got some data in each table that has no corresponding keys in the other table. So let's look at how to join these. So let's start with the join approach that we've been using. If I use this type of join, let's take a look at what's going to happen. I have two customers for whom there is no invoice, and I have one invoice for whom there's no customer. So if you look at the results, I do not see any invoices. I don't see Julian or Champy listed in my results because they don't have an invoice. And likewise, I don't see invoice number 5 because it has no customer. So all of that stuff got filtered out. And there may be a reason to have that in the table. When they run a report, maybe somebody says, hey, I want to run a report of all the customers and I want to see all of their invoices. Well, they didn't say they want to just see customers with invoices. They want to see all the customers, regardless of whether or not they have an invoice. And that might be a pretty common request in a report. So in order to do this, we have to use an outer join. The first way I'll show you to do this is with the traditional approach, where you put a plus symbol, and you can see that in the parentheses in my where clause. We put a plus symbol on the side of the condition that has the table that we want to show null values, where there is no corresponding record. So in this case, it's going to select all the customers, and if any of those customers are missing an invoice, it's going to show a null for the invoice number, or for the invoice date in this case. So let's take a look at what the results would look like. So you can see here it selected all of the invoices and gave me a null where the customer was missing. And likewise, I can move that to the other side, and let's see what that looks like. And now I have a null on the invoice side. So it's showing me a null invoice date even though that customer doesn't have an invoice. So this selected all of the customers and then showed me a null invoice date if there was no invoice. This with a join keyword using the join approach, but we add a keyword, and in this case we're going to do right. So we're going to start with a right join. So there's a right join, a left join, and a full join. Now you could also do right outer join or a left outer join, but it's not necessary. It's implied if you're doing right or left, it has to be an outer join. There's no such thing as just as an inner join that's right or left. It wouldn't happen. So in any event, what is the right signify? Well, the right says take the table that's on the right side of the join keyword. So the table that's on the right side in this case is the invoice table. That's the table that we're going to select all of, and then we're going to show nulls for any records that don't correspond from the initial table we selected. So in this case it's going to select everything from the invoice table, but we're going to see null customers. So let's see if that works. And there's our results. And likewise we can do a left join. So a left join is going to show us all of our customers regardless of whether or not they have an invoice. So there's our results. We have all of our customers listed, and there are 2 null invoices because 2 of our customers have no invoices. We can also do a full join. So a full join is going to select everything from both tables, and anything that has nothing that corresponds is going to show us a null. The interesting thing about this is you can't do this with the traditional approach. So there's no way with the traditional approach to do a full join. You can only do that with the join approach. So you can see in my result table, I now have all of my invoices and all of my customers, and there are nulls on both sides. The last type of method we're going to talk about for combining tables is set operators. So a set operator is where you take a result set from multiple tables and you combine them together in a different way than we've been doing. And the way you do that is with the union keyword. So we're going to talk about a union first. So the way a union works, if you just use the union keyword, you select from one table, and then you select from a second table and you put the 2 together. Notice in my select statement I have F name and L name, and in the bottom one I have first and last, and that's because I have 2 different tables here. So this might be one table that's all of my customers, but maybe I imported old customers from some old database and I didn't want to put those into my real customer table for whatever reason. But maybe I need to output reports or allow people to search for customers that are in both tables. So the most common thing I'd probably want to do is when I select from both of these tables, I want to show all of my customers, but I don't want any duplicates. And that's basically what this will do. So the first thing it'll do is take all of the records it finds in the first table, and it will add all the records from the second table without any of the repeats. So you can see I already have a William B. and a Dink Meeker in my first table, so they're filtered out. And then it simply lists the first set and then the second set. So pretty straightforward. The next type of union is union all. And this will simply take all of the records from both tables. It doesn't care about duplicates or repeats in the records. So now we'll see all of the records, even if they repeat. So you can see that William B. repeats and Dink Meeker also repeats in our result. The next one is a minus. So with the minus operator, it's going to select only the people in the first table that do not exist in the second table. So I've got 4 people in the first set that are not repeated in the second set, and then it's going to output just those. So the question that this type of query might answer is, show me a list of all of the customers in my regular customer table that do not exist as old customers. So just give me everyone that's not an old customer, that was not in the old customer table. And likewise, we could do the opposite with the intersect keyword. So with the intersect keyword, we can identify, and I'll show you the results here. So we can identify all of the customers that are only repeated in the second table. So select the first set, tell us where it intersects with the second set,